Well, hello guys, here Mr. G with another video. This is a video for the grade 12, but it's also applicable to the grade 11. It is related to Newton's law, and it's a question 2 from a diagnostic exam for 2023 developed by Professor Rodriguez. This question said 2 blocks of mesh 5 kilograms and 3 kilograms are connected by a string scale. They are accelerated by a mesh suspended from string B, which passes over a pulley fixed to a table as shown in the diagram below. The mesh of the pulley and the string is negligible, and the table top is horizontal and frictionless. Now, those are very important details here we're going to be speaking about. The first important thing is to know that the string that is coming here from the 5 kilogram block, this one here, is also going to be tension C. So if we call this one, for instance, tension C, that one there is also tension C. That is very important. The other thing is also true for the string B and A. This two is the same string, and therefore they are the same. So if this one is tension A, for instance, and this one here is a tension B, don't look at the size. You know what? Let's fix them here quickly. This one here is tension B, right? You need to know that tension B is equal to tension A, because we are talking about the same type of rope, the same string there. Okay, so that is the very important thing I want to mention, because we're going to need it for the answer. And then it's also going to point out that note that there is not friction. So the frictional force here is going to be equal to 0. All right. So if we carry on, they say when the system is in motion, the spring scale reads 12,5. So this one here, guys, is going to be tension C. That is equal to 12,5 Newton. That is important. It's given to you. State Newton's second law of motion in words. Now, Newton's second law states that when a net force acts on an object, the object will accelerate in the direction of the force. The acceleration is directly proportional to the net force and inversely proportional to the mass of the object. Guys, if you go to the formulas that they are going to give you in the exams, here at this point when they say forces, the very first force you will find there, this one here is Newton's second law. Second law of motion. Now, if we go back here, all right, and we rewrite that formula, net force is equal to mass multiplied by acceleration, and you rearrange it. For the acceleration, you get that acceleration is equal to F net divided by mass. Guys, from here you can deduct the law if you want to. So if you think you are going to forget the law, all you have to do is to write the formula and then deduct it from the formula by rearranging in terms of acceleration. So from here we can see that acceleration is directly proportional to F net, and the acceleration is inversely proportional to the mass of the object. Know the following: you cannot do it in symbols because the question says state in words. But anyway, if you think you are going to forget, all you have to do is to write Newton's second law, which is given to you, and rearrange it in terms of acceleration. So let's go to the next question. The next question says draw a label free body diagram showing all the forces acting on the 3 kilogram block. Now we're going to do the free body diagram for all of them, but they only ask you for the 3 kilograms block. So here in the picture, let's see what forces are acting there. First of all, we have tension C pointing in the opposite direction there of motion. That is TC. We're going to keep it there as TC. We have in TA pointing to the forward direction, or the left direction, if I may. And you can see, remember that TA is equal to TB. But anyway, that is on the 3 kilograms block. We have here the normal force, and we have pointing down, we have the weight. So these are the forces acting on the 3 kilogram block. Let's go to the 5 kilogram. Remember, it's not part of the question, but we are going to need it. So that is tension C, there is not friction, there is normal pointing upward straight perpendicular to the surface, which in this case is the table. We have weight pointing downward, and that's all the three forces acting on the 5 kilogram block. And for the M, we have here pointing upward, we have TB, and then pointing downward we have weight. Alright, so those are the two forces acting on M. So let's draw the free body diagram now, clean in another page. So let's do it on this side. For the 3 kilogram blocks, remember, we have tension B pointing to the left, or is TA, but remember it was the same as TB. We have TC pointing to the backward, or in the opposite direction of motion. Let's try to make it as straight as possible. This one is tension C. We have the normal perpendicular up, and we have weight pointing straight down here. Those are the forces. This is a little bit longer. Let's make it the same. This one is weight. So those are the forces acting on the 3 kilogram block. For the 5 kilogram blocks, now we have here tension C pointing to the left. Tension C pointing to the left. We have the normal force, and we have weight. Those are the three forces acting on the 5 kilogram blocks. And if we go to the object M, there are only two forces acting. Those are the tension. This tension, remember, is called actually tension B, but that tension B is going to be equal to tension A. We already explained that one. And then there is weight pointing down. Okay, and those are the free body diagram. However, in the exam, in the question, they ask you for the 3 kilogram block, so this is the correct answer for the question they asking you there. Now, question 2.3 say calculate the tension in the string B. Now, we are going to calculate tension B, and this is why I did explain before. Tension B, but know the following. This object, we don't know the mass, but we know that tension B is equal to tension A. So we are going to work simultaneously with object 3 kilogram block and 5 kilogram block. We are not going to work with M because we don't know what the mass is. Alright, so we're going to work simultaneous with the 3 kilogram blocks and the 5 kilogram block. So we're going to be working simultaneous. Here we're going to say for 3 kg on this side, and here we're going to work for the 5 kg. That is how we're going to work. In both cases, we are going to apply Newton's second law. F net is equal to MA, and I show you just now where do you look for the law if you think you are going to forget. Now, what forces are acting here in the x-axis? We are going to work in x-axis because the object is moving in the x-axis. So if you go here, you have the tension A and you have tension C. Remember, we are looking for tension B, but as we said before, tension A is equal to tension B. That is important to have in mind because we're going to use it right now. So if we substitute the two forces we have tension A minus tension C is equal to MA. But tension A, we are going to substitute tension B because that one is the one we are looking for. So in other words, we have here TB, which we are looking for, minus TC equal to MA. Very slow, guys, so you can understand. And we are going now to substitute the numerical values. TB, we are looking for it, we don't have it. The tension C, we do have it, and it's 12,5 is given to us. The mass is 3 and 8. Now here we have two unknown, and therefore we are going to stop right there because we have two unknown, and we're going to call this one equation 1. We are going to do the same in the 5 kilogram block. Newton's second law, F net is equal to MA. There we go. And now we are going to go to the free body diagram for the 5 kilogram block, which is this one here. Remember, we're working in the x-axis, so the only force acting there is the tension in C. So when you substitute there, you have the TC C is equal to MA, and guys, we can substitute everything because we do have it. So this one is 12,5 is equal to 5A. So A is equal to 12,5 divided by 5, and therefore A is equal to 2,5 meters per second squared. And guys, this number now must be substituted there. That's all we are going to do. So we have now the TB, which is what we are looking for, minus 12,5 is going to be equal to 3 multiplied by the acceleration, which is 2,5. All right, there we go. And now if you calculate, you have the TB is minus 12,5 is equal to 7,5. It's a 0,5. And when you rearrange, you get that TB is equal to 7,5 plus 12,5. And this will give you 20. So 20 Newton is the answer for tension B. That is the answer for this question. I hope you understand. It's quite simple, but the question is a little bit tricky there because you are not used to work with 3 objects. Now, question 2.3.2, they say calculate the mass M. So for mass M, guys, we are going to work with this specific object M. So we're going to apply Newton's second law to object M. So here, for M, we're going to work M. Newton's second law is F net is equal to MA. All right, we're working with object M. Remember, we did draw the free body diagram. Here it is, and you have only 2 forces acting. We are going to take down as positive because the object is moving down. So here we have weight, which is positive, minus tension. In this case, is tension B equal to the product of mass times acceleration, guys. And then they have a tiny problem here. We don't have weight, but you all should know that weight is equal to mass multiplied by acceleration due to gravity. So all we're going to do is to substitute this formula in that one there. All right, so what we are going to have, mass multiplied by acceleration due to gravity minus tension B is equal to MA, and we can now substitute everything. M, we don't have it, we're looking for it. G is 9,8 minus TB, which is known by us, we just calculated, it is going to be a 20, is equal to mass, we are looking for it, multiplied by the acceleration, which we did calculate previously in the question, is 2,5 multiplied by 2,5. Now what I'm going to do, you don't have to do it. This, remember, is for you to understand. I'm going to just fix this one. I'm going to have 9,8 M minus 20 is equal to 2,5 M. You don't have to do that. You can work straight on. Now here we are going to rearrange here, and then the 2,5 is going to be moved to the left, like this one here. It's going to go to the left hand side, and the 20 is going to go to the right hand side. Okay, so saying that, all we have is 9,8 M minus 2,5 M equal to 20. This is like terms, guys. So we have 7,3 M equal to 20, and when you rearrange that one, you get that M is equal to 20 divided by 7,3, and the mass is going to be 2,74 kilogram. This is a very good question, guys. I like this question because I never saw such a question. It's not that difficult, but it's kind of new. All right, so this is question 2.3.2. And to finish here, question 2.4 is a very simple question. How will the acceleration of the block change if the smooth surface is replaced with a rough surface? So now, if you replace this with a smooth surface, then the frictional force will be different than 0, and therefore you will have a backward force. Therefore, the acceleration will become smaller or decrease. The answer is here. It will decrease. That will be the correct answer here. So the selection is decreases. Why? Give a reason for your answer. Because F net is going to be smaller, or is going to decrease. That's all, guys. That's all you have to say. I hope it helped. I hope you understand the question. It's a very good question to practice. If you think it helped, thumb up, subscribe for the channel. I'll see you next time. Mr. G here.